plane. This video is completing the previous one where we showed how to set up layer 2 VPN services. So to remind you, I'm using open source SONiC as a network operating system and GNS3 as a software emulation tool. Now, before going into the details of the configuration, let me show you this slide I've prepared to just illustrate this concept. Here, again, so you see on the left, you have the leaf 1 and 2, and on the right, you have the leaf 3. And the idea is to be able to communicate, to enable communication between the host that is residing within VLAN 10 subnet and a host residing within another VLAN 30 subnet on the right here. Bridging between the same VLAN 10, we again using layer 2 VPN is something that is done. You can check the previous video, but for now we're going to see how things are going to be routed between these two VLAN using what we call a feature called symmetrical IRB, or integrated routing and bridging. Symmetrical, why? Because routing will happen on both ends, the local end, the local leaf, and the remote leaf. For this to happen, first, we have to create an IPVRF that is dedicated for the tenant on each of the ends, and then create an interface VLAN that is a kind of a routed point-to-point interconnection VLAN where the routed packet will go through it. Okay, in my case, it's interface VLAN 100. Okay, interface VLAN 100 obviously is part of the IPVRF, but also VLAN 10s and VLAN 30 interfaces. So the routing will happen like this. Packet will be arriving on VLAN 10 interface, routed over VLAN 100 to the other end, and then routed back again on VLAN 30. So routing happening on both ends. That's why it's called symmetrical. Now, for this, of course, to happen, BGP control plane, BGP has to do the magic via control plane. So leaf 3 basically has to advertise the IP prefix, meaning that these two subnet, to leaf 1, while signaling the VNI 2000 to be used in the data plane, meaning leaf 3 has to tell somehow to leaf 1, listen, if you want to send a routed packet or packet that has to be routed, you have to tunnel these packets using VNI 2000. That's how leaf 3 would know that these, by looking to the VNI ID 2000, that it has to be routed within the IPVRF routing forwarding routes. The prefix route is a special BGP route within the layer 2 VPN EVPN sub-address family, or it's called also type 5. It advertises IP prefix and also map the right VNI, which is VNI 2000 here. Okay, so what I'm going to do is I'm going to keep this window here open and same time go to the configuration. Okay, so this is leaf 1. Okay, I'm going to go into SONiC CLI. Okay, and first thing to do is to show you the VRF, the VRF that is configured within leaf 1, for instance, here. Okay, and you see that within VRF that I call VRF tenant 1, you have the interface VLAN and VLAN interface VLAN 10 and interface VLAN 100 that are part of this IPVRF. Of course, same thing is on the other leaves. Okay, so next thing to check is how I configure the interface VxLAN. And you expect here to have the mapping between the VRF and the VNI. So this what will enable the if you like the use of this specific VNI in the BGP prefix route advertisement. Okay, but also you need to map VLAN 100 as a layer 2 VPN with the same VNI. So this will enable the advertisement of other type of prefix route, which are the MAC IP route or type 2. This will advertise not only the host MAC, but also the host and IP host MAC IP of the host. So it would be the IP/32, in fact, the host IP of the host. So what is missing now? Of course, missing the most important part, which is everything is important, of course, but that is a crucial part of BGP. So within BGP we have to set some configuration that are only relevant to the VRF of our tenant. So this is where we inject our subnet within BGP. So here this subnet the subnet for VLAN 10 is being injected into BGP as an IPv4 unicast and then advertised. And now it is advertised via layer 2 VPN EVPN prefix route type 5, okay, to the other end. Okay, so meaning this here I'm advertising this specific subnet and map to that specific VNI. That what this configuration is saying. So if I go logically to the other end and I have it here, in fact, I simply am gonna retype the command for you. So I'm gonna go show BGP layer 2 VPN EVPN route type 5. Sorry, type, in fact, it's the name of the route, not the type ID. So you see here that I'm receiving from leaf 1, next hop, I'm receiving this subnet /24, which is a type 5. And the remote MAC is the MAC of the interface VLAN 100. Of course, for the routing to happen, each leaf should know what is the remote MAC on the interconnection VLAN. All right, and you see here also this same leaf 3 is advertising type 5, this subnet /24 to the other end with its own remote MAC. So meaning here, if I now check the routing table of my VRF tenant 1, I expect to get the VLAN 10 subnet here. So you see here I have the host IP, which is thanks to type 2, but I also have this subnet. Now it's connected, and of course connected is take precedence over the BGP. But if I go to leaf 1 and I type the same command, okay, so leaf 1 here, it should receive VLAN 30 subnet coming or signaled by leaf 3. So sure enough, I have this subnet /24 received via BGP. So if I go to PC3, which is, again, PC3 is VLAN 30, PC1 is VLAN 10. If I go and PC3, I do a show IP just to show you that I'm within this subnet of VLAN 30, and I ping the other end. So I have a data plane connectivity. I can go and check these two interfaces. First of all, I will check. Okay, so this is not running. So this is leaf 1 to spine 1. So here, in fact, I'm getting reply. So in fact, the echo is coming out of Ethernet 4, but the reply is Ethernet 1. You see already that the ping is tunneled via in a VxLAN header using VNI 2000. Now, if I go and check my ping echo on leaf 1 E4, so here I'm on leaf 1 E4 interface and I have the request. that is also using VxLAN 1000. And you see here, source IP is Leaf3 VTAP IP, and destination is Leaf1 VTAP ID. So yeah, I hope this was informative to you. And this will complete the how we configure layer 2 VPN and layer 3 VPN with SONiC NOS using EVPN and VxLAN in the data center fabric. Thank you, and stay tuned for new upcoming video.